Hey there guys, what's up? My name is Prateek Sharma and you are watching Spy Vision. So in this video we're going to be discussing about the data link layer. Data link layer is the second layer of the OSI model and is the second layer of the hardware control layer also. Means just like network layer, the data link is the second one. And it's basic it is basically based on two functions, that is LLC and MAC. LLC means logical link control and MAC means media access control. So LLC, what exactly is LLC? LLC, its functionality is to give when technologies like PPP, frame relay, HDLC. Exactly what is LLC is? It is, its functionality is to give you the WAN technologies. Means when we will further study about networking, we will find that frame relay is a technique that is used in WAN technologies. Means it is not useful in today's period of time because there have been a lot of advanced techniques that are being used in front of frame relay, but it is a part of that is used to establish a WAN connection in a network. It can be it is mostly used in wide area networks. So LLC is basically used in WAN technologies. It is exactly going to give you the WAN technologies. You can use the WAN technologies by these PPP and frame relay, these kind of technologies. MAC addresses, media access control. It is a 48-bit and 12-digit number which is being assigned by the help of LAN card. IEEE it has been assigned by IEEE and it has been done by LAN card of your device. It is a physical address and you cannot change it. This layer is used to detect errors in data transfer. Just for example, if a packet from the network layer is being transferred to the data link layer, it is going to detect the error through the CRC numbers. The CRC will work. How does it works? We will talk about in this video later on. Switches are the most important device of this layer. Devices like bridges and switches, these kind of devices are data link layer devices, and error detection is done by using CRC. That's what I told you earlier. If the CRC number will not match, then the error will be detected. We will find the whole algorithm, the method how it is going to be calculated, the CRC number. So there you can see how CRC will work. Before knowing this, you should be aware of XOR gate. If you are a student of electronics, or you might have ever studied gates, then you might be aware of this diagram and this if you are not aware of this diagram, you might be aware of this name, XOR gate, and you can see this truth table. The A is connected with an NOR gate. A NOR gate from B is also connected, and both are being connected to another NOR gate. That NOR gate is connected to another NOR gate, and the output of A and the B is separately being connected to another NOR gate. That NOR gate is being further being connected to the another NOR gate. So the output from A naught and B naught, which is being not by NOR gate, is being collected to this NOR gate. So after this, the truth table will be zeros. For 0 0 input you will get 0, for 0 1 you will get 1, for 1 0 you will get 1, for 1 1 you will get 0. So exactly what is doing it here is you will get the 0 output when you will have the same amount of input. If you will have the different inputs, then you will have the output positive, that means 1. And if you are giving the same input, then in that case it will be 0. That's how the CRC number will going to work. Suppose this is a message. This is a message that has to be transferred. Just think by this section, not go with the receiver right now. This is a polynomial. You can see the size of this polynomial. It has got 5 bits. This 5 bits is being subtracted by 1 and will give you 4. So this means if you are having a polynomial of 5 digit, you are subtracting 1 from that 4, and you have to add that number of zeros in that message from the back. You can see this is the polynomial, see like this is the message, and that message has got added up with the 4 numbers from the back. So when it will be divided, you will get this as the output, and the remainder is 10. Add 2 0 to the CRC because polynomial size was 4. Okay, so it is exactly what it's saying is add the 2 zeros to the CRC because the polynomial size was 4. So if you will have 6 zeros or 2 zeros, you will have to add 1 0. If you will have 6 zeros, you will have to add 3 zeros. The message plus CRC is equal to this is your number, this is your message, and this is the number which we have got as 00, and it was being instructed to do us as 2 zeros were being required to add from the start here, from the left side. So 0 and 0, then 1 0 is equal to this is the message and this is the CRC number. This number will be sent to the receiver, and that this is the received message from to the receiver. This polynomial will be going to further divided by this number, and you will get the remainder of CRC as 0, and this means there is no error that has been detected. If the remainder would haven't been 0, then your CRC number has been has detected an error. This what is exactly the how your CRC number is being calculated. Again we will going to see like this. You can see here this is a message here, this is the polynomial, what you're going to do first, you have to subtract 1 from the size of the number of bits of the polynomial. The polynomial is having the 5 bits. That 5 will be subtracted from 1, and that output will be 4. So the 4 zeros will be added from the right to the message. That number along with the added zeros is going to be divided by this number, and it will going to get the output like this. The remainder of the CRC will be 10. In that case, the 10 will be the remainder. Now when 10 will be 10 will remain here, now what the next step you have to do, your polynomial size was 4, so you have to add 2 zeros to that message from the left. Just for example, this was the message, you can see this was the message. Now you have to your remainder was 10, so kindly place that 10 here. Now you have to, from the left you have to add 2 zeros. So you have this is the first, this is the second, and this is the combined number of message plus CRC number. This number will be sent to the receiver. That receiver will receive this number, then we're going to we're going to divide this number by the polynomial that was used here also. This polynomial will going to divide it, and if the remainder is going to 0, then there is no correction that has to be done. This means that there is no error being detected here. This CRC number is going to add to the data link tail. As I told you in my previous video of network layer, I told you that the data packet from the network layer will be converted into the frame by the help of data link header and the data link tail. That data link header will have the MAC address, the source MAC and the destination MAC, and the tail will have the CRC number. So that's how the data link layer works, and that's how the data link layer calculates the error. There you can see that data link header has got the source MAC and the destination MAC. Computer A, this is the MAC address, suppose, and this is the MAC address of B. This is 67, this is 66. So source MAC is there. You have to send an ARP request first of all. ARP means address resolution protocol. It is required to learn the MAC address. So the source MAC will be 17 A2 54 32 C1 66. Suppose this is a MAC address. This is exactly the same address of computer A, and we have placed it in the source MAC. The destination MAC will be, last one will be 67. It is computer B. So from 66 to 67 it is being sending. That's why the source MAC is 66 and the destination MAC is 67. This source and destination MAC will be placed on the data packet from the header. If the data header is being transferred from the data is transferred from computer B this time now to C. Similarly, the source MAC will be 67 this time, because the computer B is transferring to computer A, which is 66. So the source MAC will be 67 and the destination MAC will be 66. That's how it works. This is the data link header. And the data link tail is obviously having the CRC number. So there you can see the data that was being transferred from application layer to presentation layer, then presentation to session, then transport transport having a transport header, making it a segment. Then the segment was being further transferred to the packet, to the network layer, was converted into a packet. Now the packet will be transferred to the data link and will have a data link header and the data link tail. The data link tail will have CRC number, and the data link header will have the source MAC and the destination MAC, and along with the total addition we will have the frame. That's how it works. So I think that's it from this video. I hope you all have liked it. Please give me a thumbs up if you like my video, and don't forget to subscribe for my future videos. You can also go through this blog site. I've created this blog site. If you are not able to access my all videos, thus far I'm giving you all the links of my videos related to OSI model, and if I'm going to make a series of any particular topic, then I'm going to give all the links in that particular series. From one video you can access all the videos. Just for example, if you are accessing my OSI model video, you can access you will find that link of the data link layer also in that description, which is just below you, below of you. You can access that by clicking that link, and that's it. That's it from this video. Thanks a lot for watching. I'll see you next time. Bye bye from here. Thank you so much.